Great. All right, welcome everybody. I'm Laura Pedicolis, the lead of the overall Eclipse Megamovie effort. I also am an auroral physicist. That's actually my expertise and what I got my PhD in. And I have done a lot of outreach on the Aurora Borealis for many, many, many years. I think I've given talks every year for 20 years, at least maybe 2 to 3 talks a year. So it's fun that we saw the aurora, and I can talk about the aurora. And I can also talk to you about some of the drive centers and sunspots, and you all, I'm sure, have had some cool experiences with aurora yourself, or you're interested in it. So I see Richard saying that unfortunately the nights with great aurora were totally overcast in Calgary. And I'm so sorry to hear that. I heard that was also true in Washington, D.C. I was in Washington, D.C. last week, and the program officer for the head of the heliophysics division was talking with us, and he also did not get to see the aurora because he was in DC. So that's very sad. All right, so we'll start. So were we gonna have people? I guess I'm just gonna ask people to share any. You can raise your hand using the little the reactions on the bottom. There's a little thing that says reactions. If you click on that, there's a raise hand. You can and then I'll call on you, or you can put things in the chat. If you have questions that you want answered, please put them in the Q&A also at the very bottom. The chat really is just for chatting with each other. But if you have questions for me specifically, or for other auroral experts, then please put that in the Q&A. And I think that before we started this, we are also going to have a moment for anyone who to share any of their HDR images or their photographs of the total solar eclipse. So I also want to make sure we have some time for that before we get started on the aurora stuff. And I see there that Tom and Kathy have raised their hands. Yes, their hand. How do I say that? Don't know.
Hey, I can show you some photos that Kathy took of the most recent aurora.
That would be great.
We've also got photos from February of 2023 when we went to Churchill in Canada and saw the aurora in a more serious way.
Yes, that would also be great. And you could tell us a little bit about your journey and where, kind of what latitude you were at, if you know. You were north.
So for the most recent one, we live in the Seattle area, and I ended up going to a little park in Snoqualmie, Washington. It's near the pass. But anyway, and that worked out really well. We saw texture in the sky, but we didn't see color. And Tom's working on sharing his screen while I'm talking, once I took photos of it, I could see that the camera was picking up colors, and it picked up amazing colors, which was truly beautiful photos. When we went to Canada at the beginning of 23, in February of 23, we saw great auroras. That we were there 4 nights and saw aurora all 4. But they were different. Every night it looked a little bit different. But I think some of the colors that I got from the aurora that we saw in the Seattle area just this past month or so, much more colorful in some ways than what we saw up in Churchill.
So it's not letting me share my screen.
Oh, I probably have to let you. Hold on.
Oh, no.
That's not a permission thing?
It's a permission thing on my computer. The Zoom app doesn't have permission to share my screen.
I see.
So it's not something that is in her setting?
No.
Okay.
Oh, no.
It could be. Troy, can you look? I don't have the security setting for some reason. Maybe you do in your Edion.
I don't seem to have a way to give them any ability to share screen, which kind of implies that they may already have it.
Yeah,
Do you have
Yeah,
the
no, it's
button
on
that
my
says
side.
share?
Tom's confirming it's on his side, and he's working to convince his machine that it's going to be okay.
Okay.
So I have to quit and reopen. So
Okay, we'll be back in just a minute.
Okay, sounds good. We'll go to Tammy King. Perfect timing, Tammy. Are you raising your hand to share? You're still muted.
Yes, I am raising to share. I've got just a couple here that are pretty nice. I'm also in Washington, but in Northeast Washington, about 48 degrees north. It was, I've been a sky watcher since I was 12 years old, quite a bit older than that now, and I've never seen it anywhere near like this. I've lived along the Canadian border, either side of the Canadian border for my whole life, and it was incredible. So, just 1 second, I'll pop up a couple quick.
Great.
and we're good to go now.
Okay, great. Tammy, as you're starting? There we go. Nice.
Yeah, so, like that was pretty amazing. We have some video of, in fact, if you look right up at the top center there, you can see the 4 stars of the bucket of the Big Dipper. They're kind of straight up there.
Right by the satellite track.
Yeah, just below the satellite track there. So yeah, this was taken with a DSLR. So about a 3-second exposure, but the color was incredible. I'll grab another one here real quick, just 1 second.
Yeah, I'm glad you're talking about your exposure time because I'm really interested in people's what exposures they did and what they got. I couldn't do it. Well, anyways, we'll talk more about that. Yeah, presumably people use different exposure times as they were taking pictures of the aurora.
Yeah, on this one, the greens just came out like crazy, and at this point in time during the event, that area that's just north just above the tip of the tree there, that was just in constant motion, and it was like you were traveling through this lighted tunnel that had all of these different colors coming at you, and every now and then it would flash in there. There's kind of this little thing right over in here was just kind of a flash that was kind of starting at that point. We actually had some video of it that we took with an iPhone that was actually really cool. I mean, it's like traveling at warp speed or whatever you might want to say at that point. But yeah, it was an amazing event. Absolutely amazing. I don't know, one more or are you good?
Yeah, do one more. Although I'm not sure that did it change for everybody? I feel like that first one might still be the same one I'm looking at. So I think when
Oh,
you
you're not seeing all the
Same
green
here.
and stuff?
no, you got to go to maybe share screen. You got to share. It says usually there's something that like says share more or share next or
Oh, okay.
unless you picked your desktop, which sometimes people don't do.
I thought I was picking desktop, but I apparently did not. Let's try new share.
Yeah, new share. That's what it is. I couldn't remember.
Now where did it go? Now it's gone. Okay. There it is.
Oh, there we go.
Wow, look
Yeah.
at that.
Holy
Fuchsia
smokes. My goodness.
was crazy the fuchsia, and this is the one I was saying. It was like you were, traveling down this, well, looked like, some sci-fi movie warp kind of effect or something like that. Of course, this is brighter than what you could see with your eyes, but I mean, this whole thing was moving. You see the lines kind of radiating out from right towards the center, just above the top of the tree. It was like that was the source of everything. It was just kind of coming around us from that point. Um, so yeah, it was really fun. It was really cool. I think I might have one more that's got some cool purples in it. Just one second.
Yeah, just so those of you who are going to share next, just remember you can, if you don't share your desktop, which is totally fine, you're just picking a picture, then you go to share screen, new share to share the next image.
Okay. Share and this guy. And so that was a little more towards the northwest from where that other picture was taken, but the different shades of purple that were coming through in there, and this went on for hours. I mean, it was incredible. It was brighter than a full moon out, as far as on the ground and things, what you were seeing for light there, but it was this kind of purple light. That's why I wanted to show this one real quick. It was just like I say, an amazing event. So
That's
if you
awesome.
missed it, I'm sorry.
I know. Well, that's why we're sharing. All
Yeah.
right.
So yeah. So I'm done. I'll stop.
Amazing.
That's so cool. Thank you so much for sharing those. Okay, so we'll go to Tom and Kathy. And you tell, so you were west of Timmy King. But
Okay.
in kind of
Are
in
you
the
seeing that photo?
Yes, yes.
Okay.
Oh,
That is very cool.
Yeah, I think
Also kind of a corona.
yeah, yeah. And these are all what the camera saw. I have not retouched any of the color or done anything other than what the camera saw. I had my white balance set at a custom 3500K rather than auto white balance. That was a tip that we learned when we did the aurora viewing in Churchill, Canada. So anyway, this was one of them. My exposure times I shot like 50 or 60 photos. I'm only showing 3 today. And my exposure times were between 6 and I think 20 seconds. So
Wow, you took all of it.
here's another one. We saw it like undulating. It was very cool. Once again, no color when we saw it, but we saw all the texture. And here's our last one. So
Wow.
yeah.
And when you're saying undulating for that, was that in the second picture there?
Yeah, we could actually see it wasn't when we were in Churchill, we at one point or a couple of points saw where the aurora was moving really fast, and we didn't see that here. But we could, as you watched it, you could see that it was moving kind of like clouds when they're kind of rapidly moving across the sky. We could see the texture changing, and so that little wavy part near the top, we could see that kind of forming and undulating a little bit. So it was pretty cool.
Very cool.
Yeah, and we got some purples and some reds and some greens and a little bit of blue. And I don't remember what they all are, but we learned when we did the other aurora trip that the different colors are based on different elements in the sky that are getting hit with particles and reacting in different ways. And I don't remember, oxygen is one color, nitrogen's another color. And I don't remember what they all are.
Yeah, I'll talk about that.
Okay, great. That's
yeah, so
yeah.
I know all about that. So
Right.
we'll talk about that more, but
Excellent.
yes, very good.
And we've got a bunch of photos from Churchill on our website. It's saxton.org, saxton.org. And then that's got a bunch of information on what our exposures were and all that stuff. So
Awesome. Great. I put it in the chat, so we'll have it.
Okay, cool.
Okay, great. So Tammy King, you can lower your hand and we'll go to Heather and Cause next.
Hello. Try to share.
Howdy.
Please share. Can you see it?
Yeah.
Yes.
Yeah. So
Tell
that
us where
was
you were.
that was May 11th this
Happy
year.
girl.
It's like over a month ago. It's Arizona. Like we never expected. She actually went to Alaska
in
January for seeing the Northern Lights, but she couldn't see it. And then like one day say there's a super high solar activities, and then like local news said we might see the Northern Lights in Arizona. And then okay, let's drive to like a little bit no light pollution area, and then just 40 minutes north from the Phoenix, and then go to the Little Bit Mountain. As you can see, still highway there, but yeah, and then we park on one of the hiking trail parking lot and then set up the camera, just like a legion red sky, and like okay, and then soon like around the 11:30 start that red sky start moving, so like it looks like a curtain moving, and set up the camera for 30 seconds exposure, and then see the more like moving wave things. And also the bottom is green color, top is more blue color, not just pure red. So and that was like a quiet experience. And a lot of people in Arizona reporting, oh, we could see the Northern Light. And the next day somebody share like a same location we took the picture, and next day hundreds of people came the same spot in the middle of the night. And then unfortunately the car headlights causing to so much light pollution next day.
Darn.
Yeah, but we could see the best timing. So
That is a great story. Yeah, and seeing it in Arizona, super rare. Very, very rare.
yeah, once in the decades or something people are saying. So it's kind of like, we save a lot of money to travel to go all the way up to the north.
I know. Good job. Great. Okay. Awesome. Thank you very much. George, you're up next. And you can put your emoji hand down, Heather and Cause. That'd be great. Thanks.
Okay, I'll see if I can get this up here. Did share screen. Oh, there it is. And see one of the pictures.
Yep.
Okay, this is with a DSLR. I'm about 50 miles northwest of downtown Chicago. It was interesting that evening. It had rained quite a bit and was overcast. It started to clear up about midnight. Didn't see anything, however. So I got in my car and I was going to a little darker sky near Wisconsin or that. Still didn't see anything. Well, I went home and on the way home, I stopped at Volo Bog. This is where Astronomy Club has its meetings. And that's where I first saw the eclipse there. Had both my Samsung, which I used night mode, and also a Canon DSLR, about 20-second exposures, and took that. Let me show another screen, another shot. Stop sharing that and share another one. See this one, all right? Yes.
Yep.
Yep.
Wow.
And I'll do one
It's
more.
crazy because you can tell like the clouds are, there's some clouds in there and you can still see through, you know, you can still see it.
Yeah.
Yeah.
Mm.
So I got about 60 of them, some better than others. I was using Pix Insight, which is an astronomical imaging software, and I was looking to improve that a little bit, both contrast and details and color. I didn't get to that yet. I got other things on my plate at the moment, but that's some of what I got. So it was very impressive. The only other time I remember it, I used to live about 10 miles west of downtown Chicago. And I was coming home from work one winter and saw fancy red images over my head. That's about the only other time that I've seen aurora. So this was pretty impressive. I didn't get to it, but I wanted to use either my cell phone or my DSLR in movie mode to take some animations of the aurora, but didn't get around to that. That would have been nice to do.
Yeah, yeah, people spend a lot of money and time for some really good video. I'll show you some here shortly. Yes, Borton.
Yeah, hi. Just want to show these. So I'll confess I didn't take these. These were a friend of mine on the other side of town. I'm here in Kalamazoo, Michigan, southwest southwest corner. Which screen do you see? Oh, this one over here. I got 3 screens here. I got to get the right
Yeah,
one.
so we see the,
You see this picture here?
okay, well, yeah, it just changed.
Okay, perfect.
That one looks like exactly like Tom and
Oh,
Kathy's
sorry.
picture.
This one. There we go. Yeah, I was doing a screen grab to take a look
Oh,
at it.
it
So.
was Kathy. I was like,
I know, right?
it was
Yeah,
Tom and Kathy. It was Kathy's picture, I think.
Yeah, no, I just wanted
Yes,
to show that this one here, it was amazing to me because in the city, we didn't see it. But then a friend of ours just outside of town here took this photo and a handful of them. And you can see it through the camera. The kicker with this is all just an iPhone. Just taking images with an iPhone, and this is what you saw. So I was pretty amazed by that. So just to point that out, that exposures, all that stuff, it didn't seem to really matter as far as in this particular area.
Thank you. Yes, I was going to mention the iPhone photographs, so it's so great to have you show those. That's great. My sister was in Massachusetts. She lives in Massachusetts, in Boston area, and she went outside and I said, "There's aurora over your head." And I texted her, "Go outside." And so she went outside and she kind of texted me back and she goes, "I don't see anything." And I said, "Take a picture of the sky." So she went back out, she took a picture and she goes, "It's there." And then, so for the whole night, she went out and took pictures and sent them to me. And then we started, and then it was the same thing for me in California. I couldn't, and they looked a lot like what you were sharing there, and from those iPhones. She has an iPhone, and it was very similar photographs. And then some of my friends on Facebook were posting in Sonoma County here in California, a beautiful red aurora. So I went out and took some pictures both with my DSLR and my phone, my very old iPhone, and I couldn't do a 3-second exposure, and it was just this deep red that I could not see with I could kind of see it with my eyes barely, but not very well. So that is to say that it just shows you the response function of our cameras detectors are very different from one another. Also, iPhone has it does HDR automatically often, and you can choose 3-second exposures, and it also has a very different response function, the detector. So there's just, anytime you take photographs of a phenomena in life, you just know that how you have your camera set up, as many of you already know, because you set your camera up, like Kathy, you were saying, you change the white balance, and you change something about how your camera is going to take in those photons and turn them into a color. That's going to kind of change then what you think you're seeing. And with the aurora, that's actually very important, because if you want to actually know like what is happening in the aurora, you need to know what actual color it is, not what color your camera made it look like. Because there are actual colors that come from these atoms, like Kathy was saying, and these atoms, the atom color is very specific to a very specific wavelength. Like for atomic oxygen, it's one number of red and one number of green. And so I'm going to talk a little bit about that. I think what I'm going to do is I'm going to try to give my talk in like 15 minutes. So then we have 15 minutes of conversation, but you'll have kind of an overview of the aurora. And you all just did the first like 10 minutes of 20 minutes of my talk anyways, since many of you seen the aurora and took pictures. So I usually start my talk that way. So I'm going to do a share screen here. And then you're going to tell me how this worked. Okay, so do you see all these pictures? Okay.
Yes.
Okay. All right, so we just did this part. You know, you can chat, Zoom. All right. So I lived in Eugene, Oregon. That's where I grew up, and it was cloudy most of the time. And but I got my physics degree and my math degree at the University of Oregon in Eugene. And my mom would talk about aurora because she grew up in East Aurora, upstate New York, outside of Buffalo. And then she would tell me what the aurora was, but I never saw the aurora here. And then I went to Winter Park because I was tired of being the only woman in my physics class. And I thought maybe there was something wrong with me. So I'd go skiing with my sister in Colorado and take a break from all that physics stuff. And I had a blast. And I met people and there who were also ski bums like me. We were working in the cafeteria. And they were like, oh, well, we work on the winter, we work in the ski mountain, and then we go to Alaska where we clean fish. And I was like, and I had a VW bus that looked just like this VW bus, and they wanted to just hitch a ride with me up to Alaska. So they convinced me to go to Alaska, which of course I wanted to do. And as we were driving up the northern Yukon, this is what we saw one night. And it freaked me out. Like it was such a crazy, just like it probably was so kind of crazy to see this for all of you, but to really see it, not through a camera, but with your eyes, it literally looked like this with my eyes. And I was like, maybe that's the aurora that my mom was always talking about. So that was kind of my first sighting of auroras. And then this is the Geophysical Institute where I worked to get my PhD studying the aurora borealis. And I ski jord. I had a dog and they pulled me on skis. And this is my advisor, Dirk Blumertime. I just have to give him so many kudos. He was so awesome. And just, you know, really making sure I knew my physics, but also just very kind soul. So I want to just thank him. Okay, so now I'm just going to show some more pictures. Most of these are from Canada and Alaska, just to compare with what the kind of pictures you just saw. And that you might see kind of further north. These are kind of similar to some of the ones you did see. Here's this purple lower border. You see it's on the bottom of the green. You all were seeing things on the top, kind of more like this one. And here's some other, these are called the corona auroras. So some of you showed us corona auroras, actually. And then here we have some more auroral arcs. There's something called black aurora. It's these little black kind of spots, areas within a more diffuse green aurora. And they move and change and turn into little features. So this is a video by Eric Chang, who works in Silicon Valley, and he posted this and made it available for free for anyone to use. And I love to show this because it gives this kind of a sense of what you all were saying, is like it was moving. So right now you'll see the stars in the background are moving. So that means anytime you see the stars moving, like right now, this is not a real-time video, clearly. This is a sped up video. And so you can see, you'll see kind of those are clouds. You see the stars moving. That means it's sped up. Here you can see some green, some red, some green on the horizon. Again, though, this is not kind of real time. This is over the course of hours. And then, you know, he's just taking a time lapse. That's what it's called, time lapse. Okay, so, and clearly with a very nice exposure, time exposure. And he put this nice music in the background, which you may be able to hear. So, and this was up in Alaska. You can see the satellites across the night sky there. You see this sky. You're starting to see some greens, some reds. Okay, so look at the stars. The stars are no longer moving, but the aurora is moving. So this is real time. Up in Alaska, you can sometimes see the aurora moving this fast. And it is a sight to see, let me tell you. If you go up to Fairbanks in March, it will be cold, but typically the skies are clear. And the aurora happens primarily in the fall equinox and the spring equinox. But in Alaska, the fall equinox is very often cloudy. So the aurora happens, you really want to do auroral viewing in the spring equinox. And now you can see the stars are moving. So this is a time lapse again. But still so spectacular. Okay. So that gives you kind of a sense. This was a picture that Chris Tarrant took many years ago, back during there's Solar Max. So I'll talk to you about Solar Max. This was even a longer time ago. Again, in low latitudes, these are the kind of things that you all got to see. So where is this all happening? The way I like to talk about the aurora is if you got in a car and you drove straight up for 60 miles at 60 miles an hour, you'd hit the green aurora. If you keep moving up, you'd hit the red aurora, and you keep going up and you see that the UV air glow. So these are in miles. We tend to talk in kilometers in space physics. So the 60 miles is about 100 kilometers. So you might hear me say 100 kilometers and just know that 60 miles, 100 kilometers, those are kind of matching. And you see a little plane down here. But we can also see the aurora from the International Space Station. And this astronaut named Don Petit, he kept a camera up there and took these amazing photographs. And there he is. And there he is setting up his camera. And this is part of the space station from another part of the space station looking at it. So you'll see the space station, and then you're going to see Earth underneath the space station. So there's Earth. There's Earth moving really fast. And here you can see the aurora. And then you can also see what's called day glow, which is just the atmosphere glowing. It's not aurora. It's just the atmosphere itself glows in green and red also. Similar processes, but not. So we can talk a little bit more about that. So you can write all your questions down. But I love these videos so much, flying over Earth. So this is what these astronauts see as they're flying over our Earth. These are time-lapse videos. So again, they're sped up. But you can see like some of these aurora reaches very high up into space. And this layer is where what I like to say is that layer of where the aurora occurs or the air glow occurs is the region where space weather meets Earth's weather. So Earth's weather can propagate up until very high into the thermosphere. And then you also have storms from the sun that impact that region. Okay. I'm not going to play all of this, just wanted to. Okay, so now we're going to do a kinesthetic activity. So I'm going to stop for a minute here. Okay, and I'm going to stop sharing. Okay, so we're going to do a little kinesthetic activity that I created called the Aurora Dance. And Darlene is laughing because I've been doing the Aurora Dance with Darlene for how many years? Like 20 something. I don't know, many, many, many years. So you may, or you don't have to, but you may, I'm going to get rid of my, choose my video background. I'm gonna get rid of this, none. Okay, so you may stand up with me, or you can sit down and do it, either way. It depends on how you're feeling, but I'm gonna stand up. Okay, so the only thing that matters is from your waist up. We're gonna assume from your waist down, it's the earth. And then your atmosphere is from your waist up. And the thermosphere, where the aurora happens, at 60 miles is your head region, above your shoulders to your head. And then we reach into space with our arms like this. And our arms are representing the magnetic field of Earth. So if you're at like Seattle, your magnetic field actually goes like this in the room. In California, it's more like this, which is really hard for me to do. So we like to go back up to the North Pole, near the North Pole. If you were right on top of the North Pole, all the magnetic fields, the magnetic North Pole, that is, all the magnetic field would come straight down into our atmosphere. Now, where the aurora happens, there's a little bit of a tilt. So we're going to tilt our arms a little bit in a minute. Okay, so shake out. That was a little tiring, maybe. Okay, so our upper atmosphere is mostly atomic oxygen. There's nitrogen down at our shoulders and all the way down. We live in nitrogen with a little bit of O2 oxygen, molecular oxygen. But up at the higher altitudes above your shoulders, it's all atomic oxygen. Okay, so what happens, we're going to assume our hands are electrons, right? Electrons are part of our atoms. They orbit atoms, so we can twiddle our fingers and thumbs for our electrons. Okay, we reach up. All right, so there are electrons out in space, out in our magnetosphere, and those electrons, they spiral around magnetic fields because of a force equation, and they come down and they hit the upper atmosphere, and they excite it. They excite all the oxygen atoms, so you move your head up, it's so excited, and then when it stops being excited, you blow out your photon. Okay, so that's your light. Okay, and those are bona fide scientific terms. Atoms are excited, they get excited by electron excitation, and then they emit a photon. And that photon has a wavelength, you know, like a wave, a color, a very specific color. And the two colors that come from atomic oxygen are red and green. Nitrogen emits blue and red, which makes purple. And then you also have ultraviolet and infrared colors too. That's right. Like, Gary's got the colors ready. Okay, so now I'm going to show you my slide that kind of debriefs us all. Usually I have us do it one more time, but I think that was plenty. And I'm going to share this and we'll do this. Okay, so to recap, your arms were representing our magnetic field on Earth in Alaska. Your hands were these electrons, these particles from space. Your upper body represents the atmosphere. And your psi represents the auroral light. And the colors in the aurora, so red and green, come from single oxygen. And pink and white, blue and red are molecular nitrogen. So here's another graphic without the whole kinesthetic thing. We've got electrons raining down on our atmosphere due to electrical currents powered by the solar particles, and I'll talk about this in a minute. The molecules are excited. Molecules give off light it's called relaxation. It's not called calming down. So here's a more I think NASA made both of these graphics. So you can see 60 miles below. At 60 miles, you get this purple. It's really below 60 miles. You get this purple lower border. You get oxygen and oxygen. And so the reason that, do I go back into this? Yeah. So, you know, if you took a spectra of this line, of this red, and it told you that it was exactly this color of red, this exact wavelength, you would know that it was coming from oxygen. And that's what solar physicists, I mean, that's what auroral physicists do, is we take spectra of the emissions and we say, okay, we know what these are. We can calculate them using quantum mechanics, and then we know that number. And so that's how we used to study the aurora before we could fly underneath it or send satellites above it. Okay, and then you've got the green that is at a lower altitude, and the pink red, this is that nitrogen emission below the oxygen. And as we've talked a lot about, our eyes have a different response function than our cameras. And so we see different things than our cameras see. And so our visible light sees this 400 nanometers to 700 nanometers. And then infrared, our cameras are more tuned to the infrared, so they're more sensitive in the red. And I'm wondering if maybe the iPhones are also more sensitive to blue, creating kind of this purple light. Or if there was some ultraviolet that your cameras were sensitive to as well, and you were seeing some of that ultraviolet aurora that our eyes will never see. And we're not sure yet. The aurora scientists are still studying this. So it's very exciting. So, but if we talk about this ultraviolet light or UV light, that's what gives us tans, and we protect ourselves with UV sunscreen. If you look at if you put a UV camera out in space and you look down on our planet, this is what you see. Not this outline. This outline is what we put on afterwards. But you see this very bright, this is called day glow. This is our atmosphere glowing in ultraviolet light. And you see the aurora glowing in ultraviolet light. And this is this auroral oval that exists at the poles nearly all the time. So day glow, that's what I just talked about, and the auroral oval. So why an oval? Why is this oval here, this circular thing? It relates to our Earth's magnetism. So remember, I had us use the magnetic field of our arms to bring the electrons down to our atmosphere. And that is exactly what's happening. So there are electrons out in space, and they follow these field lines due to fundamental force equations. If you've ever taken magnets and you put a north magnet and a south magnet and you put a compass in between those, it will follow, and you draw lines where the compass needle's pointing, you'll draw these lines. So that's what these field lines are, is it's kind of making this magnetic field as visible as we can make them. It has a strength and it has a direction, which makes it a vector. Our colleagues down at UCLA made a wire 3-dimensional magnetosphere. This is called a magnetosphere. So it's the magnetic bubble around Earth. And you can see that it's elongated. And it's elongated because the sun is coming on the left side of this picture and pushing on one side and imparting energy into this magnetic field that we can't see. It's invisible to our eyes. Every time we look out at the night sky or we look out at the daytime, we are looking through this magnetic field, and it gets energy from one side and gets pushed. It's kind of like a windsock. And in fact, the solar wind, which is made up of a bunch of particles coming off the sun, that starts as the corona, which you photographed for the total solar eclipse, that then goes all the way out into space and comes all the way to Earth, interacts with this magnetic field because it's made up of charged particles, electrons and protons. And it elongates this entire magnetic field. And here's a kind of a little video of that. Can you hear it?
Magnetosphere.
Yeah, we can hear it.
Okay,
Presented
thanks.
by science at NASA.
I'll just show a second of this video.
Enveloping our planet and protecting us from the fury of the sun is a giant bubble of magnetism called the magnetosphere. It deflects most of the solar material sweeping towards us from our star at 1 million miles per hour or more. Without the magnetosphere, the relentless action of these solar particles could strip the Earth of its protective layers, which shield us from the sun's ultraviolet radiation. It's clear that this magnetic bubble was key to helping Earth develop into a habitable planet. Compare Earth to Mars, a planet that lost its magnetosphere about 4.2 billion years ago. The solar wind is thought to have stripped away most of Mars's atmosphere, possibly after the red planet's magnetic field dissipated. This has left Mars as the stark, barren world we see today through the eyes of NASA orbiters and rovers. By contrast, Earth's magnetosphere seems to have kept our atmosphere protected. Eftahia Zesta of the Geospace Physics Laboratory at NASA's Goddard.
Okay. Whoops. So you see kind of there's these two different types of magnetic fields. On Mars, you have kind of these crustal magnetic fields. Earth, you've got this giant magnetic field. You do have aurora on Mars, but it comes from direct impact of the solar wind onto the atmosphere, whereas the Earth's magnetic field is different. So these are, I keep talking about the sun. And so, of course, the sun has a big part to play in this. And if we look for a long time, we see these sunspots that show up, and they show up every 12 hours, every about 11 years. You'll get tons of sunspots on the sun. And these are north and south magnetic poles. And that's what, when you look at some of these loops off of the sun, these are, again, those magnetic loops. It's plasma, it's light from the sun reflecting off of this plasma that is attached to those magnetic fields. And so just like you all took, this is a photograph of the total solar eclipse in 2017. And here you can see some of these loops coming off of the sun. So those loops are created by these little magnetic sunspots that then structure the solar corona into these loops. And the area where the solar corona isn't structured into loops, these are called streamers right here. These are the streamers that come out of the poles of the sun. And what we saw, of course, when we, in 2024, just recently, when we took pictures of the total solar eclipse, you've got a lot more loops close in, but you also have a lot more streamers. So you have a lot more going on. This was during solar minimum. There were still some sunspots, but not as much. And then we've got, so to study that corona and to study what's coming towards Earth, NASA and Europe have this satellite that they use called SOHO, and they put a disk in front. They go out into space, it's orbiting, it's out in space, and it's taking pictures of the corona. This is called a coronagraph, and it's got, basically right here, you can see there's a metal arm that's holding this disk, and then the circle is where the sun's photosphere would be. And here is the sun, where the photosphere of the sun would be. And you can see here those same features in that 2017 total solar eclipse. You've got this part of the corona here and here and here, the three arms, kind of that, they call it the arrowhead. And you can see the arrowhead here as well. And then out here, it's even further in space. So this becomes the solar wind, this corona. And with and those type of these storms, then so those aren't storms, but you can have a coronal mass ejection or a solar flare, and they can create aurora on multiple planets, not just ours. It kind of depends where that feature ends up interacting. So does it interact with Earth or Jupiter or Mars? And Jupiter also has a similar magnetic field to what we have. Whoops, I'm not going to show that. And then you can also see how Saturn's aurora also changes. So I just wanted to show some of those pictures. Okay, and then Aurorasaurus is taking, I mentioned this, you can go to the Aurorasaurus Citizen Science Project, you can add photographs. It looks like we're gonna have another big storm coming through, so you can take photographs and upload them to the Aurorasaurus project. Okay, so I wanted to kind of get through those quickly because then I want to spend some time answering questions because there's so many things I could tell you, and I'd rather tell you the things you want to know. So What else do you want to know about the aurora? Or what was confusing about what I said? Or what do you want to know about the last aurora that happened? Yeah, Gary. I know, where? Let's help you get unmuted. Let me see if I can help. I think I can.
Okay.
Oh, you
There we
got it.
go.
There we go. Good.
I just wanted to ask if everybody was familiar with Ovation Aurora.
The auroral oval, or
Ovation Aurora is a online Aurora prediction app.
oh,
And it actually shows you the last 24 hours, but it goes up to a 30-minute prediction of where the aurora circle is going to be. And when I go to find it, I just type in Ovation Aurora, and it goes there, and you can run either the North Pole or the South Pole. But if you're showing the U.S. area, it's centered on the U.S., and it's color coded as far as the intensity goes. And it's really a great app for showing what's going on, basically real time in the atmosphere. I wish I could show it on the screen. I'd have to.
yeah, I can pull it up. Oops, I just had it.
Is that an NOAA site?
It
Yes,
is.
yes.
Okay, yeah, I've used it before.
Yes.
And if you click that, the one on the left would be for us. It'll load it in, and then you play it. Now, there's not too much activity tonight, but back in May 11th, it was lit up like crazy. There was a lot of red, and it extended down to the northern part of the United States. But they say you have a good chance of seeing aurora about 1,000 miles south of the view line.
Yep, because you can
And
actually see it
it'll
on
show a view line as a red line when it's really active.
Great. And I'm sure other people have some other places they like to go for prediction.
Mm-hmm.
So people, we could add some more stuff. I see Tammy King also has this one, which uses the same data, but it has some more, it's more the dashboard.
And if you click on the view, it'll have a list of different sites that have different types of data. And if you scroll way down to the bottom under experimental, they have a prediction for tonight and tomorrow night's view line, which is really neat. And you can see the red there when it's really active.
Right. This is where we were. In fact, it went above KP9. And there are a bunch of scientists that are working on creating a different scale so that because when it does get very, very active, it actually goes well above 9. And we really need a scale that can capture the differentiation in above 9. So they're working to kind of fix this KP scale.
Now in the blue area at the bottom, if you scroll way down to the bottom, and there's a lot of stuff there.
Oh, I
They
see.
have
This
all
is what you're
sorts of
talking
data.
about. These
Yeah, if
products.
you go way down to the bottom under experiment, you see the experimental
Yeah.
aurora view line. See that? Click on that. And that'll show you the prediction of how far south it's going to be visible and how active it's going to be.
Nice.
So that's my go-to prediction thing. I get alerts too, aurora alerts, so I have a pretty good idea of when there's activity, and then I can go to the Ovation to get a better idea of what's going on and when it's going on and where it's going on.
Great.
Does anybody know if the phone apps are any good? Because I see several for the iPhone, but I don't know if they're any good or not.
What are some of the ones you're seeing?
I am seeing Aurora Forecast, my Aurora Forecast Pro, Artican's Aurora Forecast, Northern Lights Aurora Forecast, Hello Aurora,
I don't know any of those.
Aurora Now.
But what I would do is read about them and see,
Yeah, I always look at the ratings.
look at the ratings and also look at what data they're using. If they're using NASA
Exactly.
data or NOAA data, then is probably a good app. Yeah.
I've seen a few apps that like to show you a lot of advertising, and the data is
Exactly.
not too good. Yeah,
Exactly.
That's right.
I have an Android.
Yeah, and someone was asking also about Aurorasaurus. Do we work with Aurorasaurus? Yeah, so I told Liz McDonald, who runs Aurorasaurus and also runs some of the other citizens, kind of helps coordinate the citizen science project out of NASA, that I would urge you all to join her project, especially right now while things are so active. She actually, the volunteers that work with her were able to take a photograph, were able to photograph an auroral feature that looked like an auroral feature that they named Steve, because they were making assumptions about what caused it before they knew, the scientists, Eric and Liz. So they didn't want to make an assumption about what was causing the feature. And so they called it Steve so that no biases about the physics would be had. And so they got some satellites that were passing over it, taking measurements of electrons. And also they had some ground-based, they had some ground-based photographers taking photographs, and they were able to determine that it's not an aurora in the way that we think of aurora in terms of electrons precipitating and exciting the atoms like we did with the kinetic dance, but that it's due to a kind of frictional forces heating up the upper atmosphere and making them glow. And those frictional forces are due to electrical currents running through the atmosphere. So we always have electrical currents running through the upper atmosphere. And in Alaska, it becomes a problem. They have these big metal tubes that carry oil from the North Slope down to Anchorage. And the electrical currents up in 100 kilometers, 60 miles above Earth's surface, they actually induce electrical currents through those tubes, those metal tubes, and erode the tubes. And it's really a big problem for the oil industry because they have to replace. So they've had to try to come up with some ways to break the current from flowing in this metal tube. So when they replace sections, they'll put some non-conductive materials to break that electrical current from flowing. But we used to, when I was up in Alaska, we would have, there was at the Geophysical Institute, there were these metal poles that some scientists had put in the ground to measure the electrical current running between the poles as an auroral indicator. And then a display was put where in our 7th floor where we were, and it looked like a seismograph. So it would wiggle. And we would just walk by every day. And when it wiggled a lot, we knew to go up on the roof because there was aurora above us. So that's another way to make an auroral detector if you're in the higher latitudes and expect to see the aurora. You can make yourself a little electrical current detector in the ground.
Do you think cosmic rays have any interaction with the atmosphere?
Oh, cosmic rays most of the cosmic rays make it all the way down to the surface of Earth, of course. But some of the cosmic rays do cascade, they interact with the atmosphere, and they then have what's called a cascade of particles. So they hit like an atom or a nitrogen, it dissociates into two nitrogens, but it actually decays into protons and electrons and all sorts of cool quantum, parts of the atom, nucleus of the atom. And that then also hits the atmosphere and it happens again. And so you can get what's called a cascading effect. And that there are scientists studying that, in fact. It happens in lightning. And I think there's a pretty a lot of evidence that sprites sprites, kind of this kind of lightning that happens on top of thunder clouds, are seeded by cosmic rays that interact with the upper atmosphere, or kind of the atmosphere between the auroras and the thunder clouds. And so you can set up these electrical channels between the thunder storms and the clouds and the upper atmosphere, and where it's glowing, that day glow you could see from the ISS.
Thanks.
Yeah. I got to fly around in a jet airplane studying sprites and jets when I was in graduate school as well. So that was fun.
I just learned that there's an inverse relationship between the cosmic rays and the sunspot cycle.
Yes, I think right, because I think what they think is that the sun is basically creating a barrier for the cosmic rays to get through during the solar max. Is that what you've heard?
Yeah.
Yeah. Yes. All right. Well, we're at 6:05. So thank you all for sharing your great photographs. I'm glad that many of you got to see them, and I hope that those that didn't get to see them get to see the aurora. We've got a couple years still in solar max. So keep your eyes out. Yeah, find apps that tell you, give you alerts on your phone, and also make some plans to go to Alaska if you can.
Or New Zealand.
What's that?
Or New Zealand.
Or New Zealand. Yeah. Or Iceland.
Hey Laura, I just wanted to remind about we said we were going to do monthly meetings, but of course it is the summer, so many people are away on vacation. And so next month, July, we are not going to hold our regular monthly meeting. So yay, everyone go enjoy camping, traveling, whatever you guys are doing. But we will be back on August 26th. We will send out an email to remind you, same bat time, same bat channel. Again, the Zoom link, August 26th. Again, fourth Monday of the month is what we like to try to hold for. And that one we are going to try to get the students to actually present on the AI image processing, some of that. And starting to roll to our next phase. So we would just want to say that before we signed off for 2 months because of our summer break. Any questions before I stop recording?
There was a question, a very important question, which is, can people still submit their photographs? And the answer is yes, until Friday. Or is it Friday or Sunday? We're turning it off on July 1st. I think that's Monday.
Yes, so Sunday.
We have the weekend as well. Yeah,
so spread the word too. We will get it out on all our channels, but anyone, especially that was like buddies with you and photograph the eclipse, but they weren't an official sign up, whatever, still have them submit the photos. Yeah.
Yes.
Okay.
Yeah. And if we need to, we can open it again later.
Okay. But we're trying to get it in. Okay. I think that's it. I'm going to stop recording and sign off, everyone.